Hey there and welcome back to the C# for Total Noobs training course for a new lesson. This time we'll talk about queues and dictionaries, and with this I guess we will conclude for now our lessons on collections, because these two types of collections are really the last ones that we will look into. As said, especially for the dictionaries, this is one of the collections types that you might use very often in the programs that you might be writing very soon. So let's get started. As always, we will first look a little bit into the theoretical aspects, and at least for dictionaries, but also for queues. There are some characteristics that we will have to talk a little bit about, and then we'll go over to some code and see how this works in practice. Now, last time we looked at stacks, and we said that stacks are a very specific kind of collection, because when you want to grow the collection or shrink the collection, what you could do is always push an element on top of the stack or remove an element from the top of the stack. Now the queue is a little bit different, but in certain ways it behaves something similar. But the only difference here is that we can imagine it really as a queue. So this means that when you add something to the queue, well, it actually gets well, in a sort of line, I would say. So when you want to remove something, then the first element in the line is removed. So as we can see here, actually, on this diagram, whenever we want to push something to a queue, it's actually put at the end of the queue. And when we want to remove something from a queue, it is removed from the front. So it's really like a regular queue or line when you are, for instance, in a shop. And of course, if you are the third or fourth person in queue, you don't really like that. Well, when the next one should be served, it is one that is, I don't know, maybe 10 places behind you. It's not fair. So it's exactly the same concept with the queues that we have here in programming and in C#. Now the only thing is that this type of adding data to a queue and removing data to a queue has here two specific names. Like for instance, when we add something to the queue, so at the end of the line, this is called in queuing, while when we take something out of the queue, so the first element or the next element in the queue, well, this is called dequeuing. And that's basically everything about queues that we actually need to care about. But before we go into practice, let's also look a little bit into, okay, what are some common scenarios where you might implement queues, or application types that you might encounter, and where queues might actually be very useful. And for instance, printers. We have printer queues, and these are implemented, of course, using queues. Now, email, when you want to send bulk email, it's once again, we can create a queue and then we can send one email at a time to each person. So the idea is that any time that we actually need to process some data in a first in, first out order, we have, or we can use these characteristics of a queue that we have here in C# and do this very easily. Now, let's also have a theoretical look on dictionaries, and then we'll go over to the practice part. Now, dictionaries, as said, are a very interesting kind of collection, because it's not actually a collection of simple elements, but it is a collection of key and value pairs. And the key and the value are not necessarily of the same type. So we might have a key that is of type int, and we might have a value that is of type string. The same way we could have a key that is of a custom type that we create, so our custom class, and then for instance that the value is another type or another custom type, another class that we create. So basically this is why when we talk about dictionaries and when we define them, as we see here, we always say about a dictionary of T key and T value. And remember when we talked about generics, and we said that T is actually a placeholder for a data type that we have to provide when we declare and instantiate the stack or the list and so on. Now for the dictionary it is exactly the same, but since we actually need to provide placeholders for two different types, we have one that is called T key, so this is a placeholder for the key, and we have another one that is called T value, which is a placeholder for the value data type. And we will see this in practice. So it's really nothing very fancy here. It's just regular generics. The only difference is that here we need to provide actually two data types, and that's why we need to use two different names for them. Now, the concept of dictionary is actually very important, because as said, it provides a mapping from a set of keys to to a set of values. Now, the idea is that whenever you retrieve something from a dictionary, you actually retrieve it by the key. So you use the key to retrieve or to find that element in the dictionary, and if you find it, then you can access the value. And the reason why we do this is because it is very, very fast. So in scenarios where you have to work with a lot of data, is very often far more performant to use a dictionary, for instance, instead of a list or instead of an array, because you could use data types that are very small, let's say, for instance, as keys, and then retrieve the values only when you find the corresponding key. So when you do searches, sorting, and things like that, you don't have actually to work with the entire values. You could imagine here, for instance, that let's say we could have a dictionary of string, and let's say that the key is a book title, and then the value is the entire book as a string. So if you want to find a book, for instance, if you try to search it by the content, remember it is an entire books, or we have a dictionary of whole books, then this will be very, 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 very slow. But if you want to search first by key, and only if you find that key you want to retrieve the value, then this is actually very, very fast. And the reason why this data type is actually optimized for very, very fast lookups and performance is that basically in or under the hood, it is implemented as a hash table. Now, if you ask yourself what a hash table is, well, it's nothing very, very complicated, or let's say at the first look, it is not very, very complicated, because it's just a simple class that stores data as key and value pairs. But the cool thing here about a hash table is that for the key, it actually doesn't store the value of the key itself. But instead, what happens, it computes a hash of each of the keys, and then uses this hash code to actually look up for different keys. So not the key itself, but for instance, if we have a string hello world, let's say that .NET computes a hash code for this, which could be, for instance, the number 1, 2. Now, of course, from the perspective of how much memory do we actually need for that, it's far easier, or it's way faster to work, for instance, with 1, 2 or 12 than with the entire string, because the string would probably take in more space than a regular integer. So in this case, once again, not only that it searches by keys that are really smaller than the values, but the keys actually are stored as a hash code, which is once again very, very fast to retrieve. And the idea is that this hash code is once again something that when you create an object, each object or .NET creates a hash code for it. So it is already computed by the time that it gets created. And for instance, and we'll look into this when we will go to the demo for dictionaries, whenever you create a new object, it could be an object of a type that you have already in C#, or your custom type, your custom classes, but each object you will see has this method getHashCode. So this is, and basically it means that when we use a dictionary, this hash code of the key is actually used when we try to do lookups. And once again, this is why working with dictionaries might be very, very fast and performant when it comes to regular lookups. And yeah, that should be it, at least for this part. So let's get over and write some demos here. So we are here in the same solution that we used for all the series that we talked about. The collections. Here is the undo app that we have written in the previous lesson when we talked about stacks. So let's add here a new class. Where's the add? Here is the add, and we'll call this demo. And as we did for the other demo classes, public, and let's have here a public static void run demo. Okay, and here in the program.cs, let's just set this up. So this is the app that we use for stacks. Let's comment this out, and instead of this, let's use demo.run demo, and then this should run everything that we place here in this method. So let's go back to it. Now, for the queues, once again, as they are very specific, not like lists, so here in this case, you have to enqueue and dequeue elements. Well, what happens here is that, of course, when we want to declare and instantiate a new queue, we can see here, for instance, queue of string, and here equals, sorry, let's give a name to this variable, equals new queue of string, and we create. So we don't use a collection initializer for that, because the only way that we can add elements to the queue is by enqueuing them, and the only way that we can remove elements from the queue is by dequeuing them. So this means that we have this method enqueue, which will add an element to this collection, this queue. Now let's add first this one, and let's also add another one. I guess it's good to add 4 because we will perform some operations on them. We will add exactly the same that we used also for the stack demo and for the list, and we always use this enqueue method. Now the third one should be list one, and then the fourth one. So once again, this enqueue method is actually, or enqueue method is actually what adds things to the queue. Now, of course, when we want to access elements and remove it from the queue, we need to use the dequeue method for that. But until we get there, of course, we can then iterate through this collection, and we can see that for each var city in cities, and here we can simply write the city to the console. So as it is for any collection, we can use a for each loop to go through all the elements. And in this case, yeah, we just write the city, and if we run the application, I guess that this should work just fine. So there shouldn't be any problem here. Okay, so we have this working. Now let's move over, and I will once again use some code that we have already written. And here we will want to also showcase how this actually works. So the different methods. You will see that it is not really complicated. It's working mostly exactly the same as we have, or we had in, for the stacks. But the main difference is that we use the enqueue method to add to the queue and the dequeue method. And what we do is very similar to what we have done for the stacks. So first we just want to count all the elements. Then we see which is the first element, and we dequeue it. And then we see we check once again for the count, and we will see that in that case, basically the count of the elements will shrink, because with dequeue we just will also remove the element from the queue. But then we use this peek method, which does exactly the same what it did also for the stack. So it returns you the element, so the first element in the queue, the one that would be dequeued the first, if you want to do that, but it doesn't really remove it, so it stays there. So it's just a peek into, okay, what would be the next element to be dequeued, but it actually doesn't perform the action itself. And that's why we then have another count to see that it actually remained exactly the same. So let's run the application again. And we see that the first time we have here number of cities in the queue is 4. Then we have this, the first city in the queue is Seattle. And now the number is 3, because remember, to retrieve the name of the city, we use the dequeue method. So this means that it also removed it from the queue. So in this case, the first city in the queue remained Munich, the next one. And of course, the current count was actually decreased to 3, because we have right now only 3 elements in the queue. Now, what I wanted to show you, why is the queue very, very important? Because you can process information in the order that it arrived at a certain point. So you might have a class, for instance, that collects a lot of information from different places from the application. And it's very important for you that you process all this information that you received exactly in the same order that you received it. So in this case, you can simply use a queue and dequeue one element at a time, perform the logic that you need to perform, and then basically move on. And that would look something like, for instance, let's say that we want to process all all the cities that we have here in this queue. So we can we can then, for instance, use this while, and we can say that while cities.count is greater than 0, so while we have elements in the queue, then perform an action. Here we could add whatever logic we would need, but in this case we can just console writeLine and cities the queue. And this means that each time that we dequeue a city, the count will actually shrink. And when it reaches 0, then we will go out of this for loop. And yeah, then it means that all the processing is done. So we have finished to process all the information that needed to be processed. Now here we can then write another console writeLine, and we see that the current count should be then 0 at the end. So let's run this application again. And here we see that current number of cities of the queue is 0, which is totally correct. Once again, this is just to show you and to simulate how you would or you might use a queue in real applications. So you might need to process information based on each element in the queue, and you need to have a warranty that you really do this in the order that that specific information was actually generated. So you can just dequeue an element one at a time, perform the actions that you need to do, and then you can use this in a while loop. And when the count is 0, then you are finished processing, and you can really exit that loop and then do some other stuff that you might need. So this kind of setup might be something that you might encounter often when you work or when you will work with queues. Okay. So I guess that's everything for queues. Let's also briefly do some demos on the dictionary. And here on the dictionary, as said, this is a collection of key value pairs, and I will show you basically the functionality that we need or that we use virtually any time that we work with dictionaries. So here we have a dictionary demo, and we'll set this up exactly like we did for the queue. So it is a public class, and let's have public static void run demo. Okay, and then in the program.cs we can just comment this out, and then we can see here dictionary demo dot run demo, and we should be fine. So let's go back to this one right now. Good. So as said, when we work with a dictionary, this is a collection once again of a t key and a t value, so of a key and a value. So this means that when we declare a dictionary, we have to provide two data types, one for the key and one for the value. So we have to replace the placeholders that we have discussed when talking about dictionaries, so the t key and the t value, with the data types that we want for the key and the data type that we want for the value. And let's assume that we are building a real dictionary, so where you have a word and then you have a definition for what this word actually means. So in that case, we would have a dictionary of string and string, because we have string as key and we have string also as value. And let's call this English because it should be a dictionary for the English language. And here we can have a new dictionary of string. But the thing is, here we can also use collection initializers, because here we can simply add key value pairs to the dictionary or remove them. So from this perspective, it's a little bit similar with the list. The difference is, of course, that here we have a key and we have a value. But in this case, we can just go on and use a collection initializer to actually define the data of the dictionary if we already know it. So let me just use this what we have here. So I'll just paste. So we paste here once again a key value pair. So this is a key value pair, and it should be of string and string. So we have home as a string, and then we have the definition, which is also a string. Then we have the second, and this once again we have a key, which is a string, and we have here a definition, which is actually the value. And of course, if you don't know at the time of creation all the data that needs to be placed in this dictionary, as said, it's very similar to the list. Very simple, english.add. you just add an element. Now, the only thing is that here you have to add an element once again as a key value pair. So we have to provide a string as key and a string as value. So let's provide here a string as key, which is computer, and let's have here a value device practice programming. And just like that, we have added a new element to the dictionary. So this means that if you have some of the key value pairs when you create it, you can use the collection initializer. But if you need to add elements afterwards, you can always do that. So yeah, it's up to you to use it the way that it really fits what you are trying to do. Now, what I wanted to talk about your dictionary, because actually, I said it's a regular collection with add, with remove, and things like that. But as said, the most important part of dictionaries is that we can use. They are highly optimized to be performant for lookups, especially if you want to look up for the key. And this is why the most common functionality of the dictionary that you will probably use and encounter is the concept of trying to find a value by its key. And this is very, very, very nice and easy to do. But for this, let's try to find, for instance, the definition of a certain key. So the definition of a certain word. So let's have a string definition. And once again, here we just declare the string for now. We don't use it. And now, this is the part where it gets a little bit interesting. Because let's have here a bool is present. So if a certain key is present in the dictionary, and then we can say here in English, so this is the dictionary, and then we have this try get value. And the try get value method is very interesting because it accepts an argument for the key. So let's see if we have a key for computer, and if we have a key for computer, then just place me that key in the definition. So this is why we use this out keyword. That's very important. So always when you try to do lookups in a dictionary, you just use to provide an out parameter. Because here, for instance, what happens, or how we could describe here what happens is that please try to find me this key. If you find this key, then return me true. If you don't find this key, just return me false. But in case you find the key, then please just also put that value or the reference in my variable here so that I can use it. So in this case, I could simply say console.writeLine, and here I could write the definition. Like this, I guess. And I can also console.writeLine, and here I could, for instance, put the is present. Okay, so let's run this application right now and see if it finds it. Okay, so it says here device to practice programming. So this is the value, this is the description. So we also have true, so it means that we have found that key. Now, for instance, if we look here for something else like programming, we don't have this key. So let's run the application again and see what exactly happens. In this case, we see that it doesn't print anything here because the string is null, of course, and then it prints false. So the idea is that this try get value method always returns you a bool. So true if it found the key and false if it didn't find the key. And this is why you could easily use this method, for instance, in if statements, because you can easily place this in an if statement. And then, of course, if this will be true, then you can do some stuff. But if not, you can simply just go on and continue with other things that your app might need to do. But in case it finds it, it also places the value in this out variable that we provide here. And this is very, very important, the out keyword. So this is exactly what this keyword does. It says that, okay, if you find me this one, then just place me the value here in this variable that I have declared previously. Now, of course, the variable has to be declared in order for this to work, but it doesn't really need to have a value, at least if it is a reference type. But that's actually mostly how this actually works. And last but not least, I also want to do here an iteration with a for each loop. And here we can say for each var element in English, so in the dictionary. Now the idea is that what we want to do here is, let me just paste here a console write line that we want. So it would be this one. So the idea is that if we hover the mouse over element, we see that it is actually a key value pair. So this means that inside this for each loop, if when we use the element, we have this key property and we have the value property. So in this case, we can print to the console, for instance, each key and the value of each element. So if we run this, it would do exactly the same things that it did previously, but here in this case, it also just prints out all the keys and the values that we have in that current dictionary. So this is once again important because when you have a for each loop through a dictionary, you always get a key value pair. And on the key value pair, you have then a key property and a value property, and you can use them individually. And that could actually prove useful because you might want to order by keys or order by values and things similar to that. So in that case, you can simply just use these properties that we have on the key value pair. And yeah, that's mostly it. With this, I guess we covered the most common collections that we have in C#. And starting from the other lessons, we'll try to actually do some more practical stuff in which we will try to actually implement and use all the things that we have learned till now, starting with the classes, with different type of classes, with inheritance, methods, and things like that. And of course, including also arrays and collections and whatever we covered so far. So till then, thank you very much for watching. I hope to see you here next time. And until then, I wish you the very best.